Hi, and welcome to Frauscher Talks. My name is Manfred, and today we are going to talk about the individual FAdC components in detail. The FAdC can be connected to two types of trackside wheel sensors, such as the Frauscher wheel sensors RSI 180 and RSI 123. For further details, I highly recommend to watch the Frauscher Talk season about Frauscher wheel sensors. The Frauscher wheel sensors are connected to the FAdC indoor components via a signaling cable. Distances up to 10 km are possible without any specific requirements. Now let's have a detailed look on the indoor components. As you have already heard, the wheel sensors are first connected to an overvoltage protection board, BSI. The purpose of the BSI is to protect the indoor equipment against induced overvoltages originating from the wheel sensor interface. One BSI is required per wheel sensor. It is mounted on a standard thin rail, and the BSI is a maintenance-free device. After the overvoltage protection, we reach the actual FAdC components, which include the power supply board PSC, the advanced evaluation board AB, the communication board COM, the backplanes, backplane power and backplane EXP, and lastly, the input-output extension board IOXP. Let's start with the power supply board PSC. First, it protects against overvoltages and overcurrents on the power supply interface. Secondly, it powers the COM boards and the internal communication bus, the CAN bus. In order to be able to minimize the impact of a single point of failure, the PSC architecture allows a redundant power supply setup. Next, we are concentrating on the advanced evaluation board AB, the axle counting brain of the FAdC. One AB can only be connected to one wheel sensor. It powers the wheel sensor and evaluates the wheel sensor signal. AB digitizes the analog signal into counting head information, such as wheel sensor system occupations and traversing directions. A counting head is the equivalent to a detection point. Here, I would like to refer to the Frauscher Talk season about wheel detection. As we have already heard in episode 1, one AB can also be defined as an axle counting board. The limitation here is that one AB can at most evaluate 2 track sections on its own. In total, a maximum of 21 wheel detection information packages can be processed and included in track section evaluation by one AB, including its own. The example shows a possible maximum configuration for an AB. Let's continue with the input and output extension board IOXP for the hardware input and output of information. This board is not a standalone component and always requires an AB for its control. One IOXP provides enough relays for the fail-safe output of up to 2 track sections, as well as necessary input interfaces for the track section reset. Depending on the FAdC configuration, the IOXP also can be used to output counting head information like the aforementioned wheel sensor system occupation or traversing direction. Another very important part of the FAdC is the communication board COM. As the name suggests, the board is mainly responsible for communication tasks. The COM board can forward axle counting information from the local CAN bus to a remote location over an Ethernet interface. This is how track sections between 2 stations can be established. The COM board basically removes technical constraints on the length of the track section. Apart from the communication task, the COM acts as a configuration server and holds a compact flash card from which it distributes all configuration files to the participants on the internal bus. The preparation of the configuration files of the FAdC can be done via an open source text editor. Frauscher even offers training on the FAdC configuration to minimize the dependency on the OEM. Same as on the power supply side, a redundant setup is possible to minimize the potential impact of a single point of failure. The just described components are assembled to backplanes. Two different types of backplanes are available. The backplane power accommodates the PSC board and AEBs and COMs. Multiple backplane powers can be interconnected by simply extending the internal bus via internal communication cables. The backplane EXP is required to connect different numbers of IOXBs to their controlling AEB. Last but not least, the backplanes need to be assembled to a standard 19-inch board rack. This adds mechanical protection and the possibility of labeling. Optionally, the board racks can be installed in a 19-inch cubicle as well. Thank you guys for tuning in again, and see you in the next episodes of Frauscher Talks. Don't forget to like, subscribe and share.